Hello, welcome back to the another video lecture under this standard results of Z transforms. Particularly in this video, we are going to deal the Z transforms for the trigonometric functions. The ninth result, what is the Z transform of sine n theta? The 10th one, what is the Z transform of cos n theta? Once we got this one, we will substitute theta equal to pi by 2, we will get sin n pi by 2 value, cos n pi by 2 value. Even when we generalize this one for r power n cos n theta, r power n center, we get the answer. So how? Let's see that. This is simply by using the result z transform of a power n. As we know that the z transform of a power n equal to mod z greater than mod a under the division of validity is z by z minus a. Now a is a constant, but this time I can take this a equal to e to the power I theta as a complex number. Generally we can take z equal to r e power I theta. R is called a polar form of a complex variable. Then we will get this result. Okay, z equal to r e to the power I theta. We get this result directly. But this time I am considering r equal to 1 e power I theta. So by using this result, z by z minus e to the power I theta. By using the De Moivre's theorem, this is powers goes into the term e to the power I n theta, and e power I n theta can be written as cos n theta plus I sin n theta. Similarly here, z by z minus e power I theta, e power I theta can be written as cos theta plus I sin theta. Now let us see that this is the real part, z minus cos theta minus I into sin theta. This is called imaginary part. So once we have a complex number in the denominator, usually we can take the conjugate of the denominator, multiply and divide. So the same concept here, take the conjugate of the denominator, z minus cos theta plus I sin theta, right? So let us multiply and divide this one. We get z into z minus cos theta plus I into z sin theta by a minus b into a plus b. It is a squared minus b squared. So z minus cos theta whole squared minus b squared. So b here, b is I sin theta. So I squared becomes plus 1. So it is plus 1 sin squared theta. So let us expand this one. Z squared minus 2 cos z cos theta plus cos squared theta plus sin squared theta is 1. So this is the answer for the z transform of cos n theta plus I sin theta. Let us equating the real and imaginary parts. So equating the real and imaginary parts. Equating the real and imaginary parts on both sides. What we will get? We will get the required series. Right? We will get the required answer. So what's the real part? The left hand side, z transform of cos n theta. What is the real part in the right hand side? I think so. Z into z minus cos theta by z squared minus 2z cos theta plus 1. Is right? Is it clear? Similarly, what about z transform of this sin theta? Because it's an imaginary part. So what's the imaginary part? Here z transform of sin theta is an imaginary part. This is a real part. So in this case, the imaginary part is I into sin z sin theta. So it is equal to z sin theta by any of the denominator is same, z squared minus 2 cos theta plus 1. Is right? Is right? And what about the regional validity? Is obviously mod z greater than mod 1 only. Is right? So this is the result, the ninth result, z transform of cos n theta and z transform of sin n theta. Clear? Now, if I substitute theta equal to pi by 2, we will get these two results. Yeah. If I substitute theta equal to pi by 2, what we will get? Can you see that? If I substitute theta is equal to pi by 2. If I substitute theta equal to pi by 2, in this result we get it is, can I substitute theta is equal to pi by 2. We will get z transform of cos n pi by 2. So cos n pi by 2. So by putting pi by 2 here, cos pi by 2 is 0, you know. So z into z squared by cos pi by 2 0. So z squared plus 1. Right, so cos n pi by 2. Similarly, by putting z equal to this theta equal to pi by 2 here, we get cos n pi by 2. Sin pi by 2 is 1. Sin pi by 2 is 1. So z transform of sin n pi by 2 is equal to z only, because sin pi by 2 is 1. Here cos pi by 2 is 0. So z squared plus 1. Z squared plus 1. So this is the answer for sin n pi by 2 cos n pi by 2. When I take the constant a equal to r e to the power I theta, then you will get this result. The real part is r power n into cos n theta. The imaginary part is r power into sin theta. At the same time, replace the cos theta by r cos theta, sin theta by r sin theta. The similar idea by replacing a equal to r e to the power I theta is a polar form of a complex variable z. Right? By taking r equal to a, we get this is a transform of a power n cos n theta, is a transform of a power n sin theta. Similarly, we can replace R by A, we will get the respective results. So that is the concept, that is the results under the trigonometry function for the Z transform value sin n theta or cos n theta and sin n pi by 2 cos n pi by 2 r power n cos n theta and r power n sin n theta. So I hope everyone understand this topic, that is called Z transform. Particularly something is very new concept, that's why I derived around 10 results under the standard Z transforms. Apart from that, we can generate some more results. For example, Z transform of n squared. So how to get Z transform of n squared? Once if we know Z transform of n, we can get Z transform of n squared, n cube, whatever. So with the help of some results or some properties or sometimes some theorems. So let us go and watch our playlist Fourier transforms, just Z transforms. Go and watch our playlist. This separate video I made for each and every theorems, results, properties. Thank you so much for watching our YouTube channel. This is signing off, ADC Max. Thank you so much.